Hello everyone, my name is Nafio. This video is about Node.js and this is basically aimed for the beginners and the intermediate level learners. Before starting this video, you should have good understanding of JavaScript ES6 or 7. You should have the concept of client-server architecture, how a client requests a server, and a server how responds to that request. Basic understanding how RESTful APIs work. What topics are going to be covered in this video series? First, I'll show the installation process of Node.js and how npm works or how you can change the version of Node.js. Then I'll give some basic understanding of Node, what Node is and how it works. Then I'll try to make you familiar with Node.js Playground. And a very important topic about Node.js. Actually, this topic is about JavaScript as well, and which is asynchronous programming, and it's vital for Node.js developers to know. So I'm gonna cover this topic. After that, we will create a basic Node.js server, and we will also create some APIs like a GET, POST, or POD. And after finishing, we will try to give some insights about the advanced topics of Node.js. Let's start with the installation process. Let's open our browser, search for Node.js installation. As you can see, if you're a Windows OS user, then you should download this Windows installer. If you're a Mac OS user, then download this. Nevertheless, I'm a Windows user, so I'm gonna download this. If you click this, you can download this, and the installation process is fairly simple. So I'm gonna skip this part, and let's assume that Node.js is already installed in my system. Once you install Node.js, you can start playing with it from your command prompt, or personally I use Windows PowerShell, and I'm more comfortable with this. Let's check if Node.js is installed or not. So as you can see, the current installed version is 12.16.1. So apparently Node.js is installed in my system. And if you want to check in the npm version, npm, you can type npm. Okay. So basically, npm is a node package manager, which is basically an online repository of the packages related to Node, and you can download and install these packages from their repository and use this in your project by simply npm install and giving the name, package name, whatever the name is. So basically this is the usual process. Now let's talk about what Node.js actually is, right? So let's go back to the browser. Wait. Let's type what is Node.js, right? Here you can see Node.js. Google says Node.js is a JavaScript runtime. What is it? JavaScript runtime, which is built on Chrome's V8 engine. Now the question is, what is Chrome's V8 engine? What is Chrome's V8 JavaScript engine, right? So V8 basically an engine which converts JavaScript code to machine code. Let's say, like in your console, this is a client application, right? It's a browser, and you're in Google Chrome. What Chrome does is, like, let's type a basic JavaScript function, which is map dot maybe random, and let's run it. As you can see, it's a JavaScript code and it's returning a value. What it does is, how it happens. Google Chrome uses its V8 engine, V8 JavaScript engine, and converts this JavaScript piece of code into machine code, which ultimately returns our desired value, right? So Chrome uses V8 JavaScript engine, right? The same way, what Node does is, if you if you want to go to the Node playground, just like this playground of Chrome's V8 engine, you can go. You have to type Node. As you can see, this arrow it indicates that you're in a Node environment when you type Node. Now, let's type the same function map random this, and it returns a value. So from this definition here, it says Node.js is a JavaScript runtime, right? So here we are running JavaScript, and then it uses Chrome's V8 JavaScript engine. Here in that runtime, Node uses Chrome's V8 engine and converts this JavaScript code into machine code and returns a value like this. So I think I am able to make you clear about this topic, like how Node is working, and the basic difference between this environment, this Node environment, and this browser environment is, browser is a client-side environment and it's a server-side environment. In a server-side environment, you can work with files, networks, and in a client-side environment, what you are doing is like making requests from just a client side, right? So there are a few more basic concepts you will have to remember about Node.js, about what Node.js is and what it's not. So first of all, Node.js is not a language. It's not a language. It's a platform. Like if we go there, and as you can see in command prompt, we have typed Node and we have entered this platform. It's a JavaScript runtime environment. So it's a platform and it uses an event-driven approach. Now, what is an event-driven approach, right? If we go to LinkedIn, that's a site. LinkedIn basically uses Node.js, and that's why I'm like using this site as a reference. So if you open the browser developer tools by pressing F12 and go to network tab, so as you can see, it's a button, right? And if you press this button, an event is called. And now I have pressed this button and an event is called and an API request is made. And the API is this one. Okay, it's a post request, and the request payload, which is the request body. You can also call it request body. Request body is this. So this information is sent to Node.js server using this API, right? This API, and it's a post request. Whenever Node.js server gets this request, it receives it and processes it, and finally it gives you back a response. The response is this. The sent response is this. This is also the response, the same response. So, and it gives you back a status code 201. So what happens here? there an event is called and an appropriate response is got, right? So it's an event-driven approach, what Node.js makes. About what non-blocking I/O is. Well, applications run on a CPU, which is the computer's brain, and the CPU has a set of thread operations. You have a, let's say you have a multi-core CPU, so you can run one thread per core at once. Like I have four cores in my CPU, and I can run 4 threads at a time, let's say. So think of a server, right? A request comes in, the request takes a thread, then calls, this is the application takes the request, and this application calls database to get some data. But until the database comes back with the data, right, it comes back, the thread is blocked, right? It's using this thread, and until it gets the data, it's blocked. So we cannot serve any traffic on the thread until the database has responded, right? So in a blocking I/O, what happens is like, let's take this metaphor, this restaurant metaphor. In this example, the waiting stuff represent the web server, and the kitchen represents the database, and the food they're serving, this food is the data being requested from the users, right? So what happens here? The waiter takes the order, he walks to the kitchen and requests the food. The kitchen staff then create the dish. The whole time this is happening, the waiter cannot do anything else as he is waiting for the food to be cooked. And this is a huge waste of resource, right? A better approach in this situation where the waiter sends message to each other instead of waiting on results. In this example, we show a similar restaurant setup. The waiter is still taking orders, but here he is passing the order to the kitchen as a message and then forgets about it, right? This is a huge distinction from the first example, because instead of waiting on the chefs to finish cooking each meal, the waiter can be alerted by the bell that is ready, right? The waiter is free to serve all the other diners because now there is a messaging system. He is no longer blocked from being able to serve other customers. And that's why non-blocking I/O is efficient. Now, let's see from Node's perspective how non-blocking I/O works. Let's say these are the customers in the restaurant, and they're making requests for food, maybe. And here is a thread. In other words, you can call it the waiter, and waiter is taking all the requests and it's communicating with the chef, where chef fetches the data from the database in a non-blocking way, and it gives back the response to the waiter, and waiter gives the response to the customer. In figure 2, you can see there is a event queue, which is also called the main thread of Node.js. There is a thread pool. Thread pool is more like a worker thread, where and the event loop can be compared to the messaging system, right? and this is the database or file system or network system from request can be completed. Here is another example how Node.js works. Let's say an application is run from Google Chrome browser, and it converts its JavaScript using V8 engine into machine code, and that's how it uses Node.js API to communicate with the server here. And in the server, Node.js takes the request in the event queue, and it communicates with the worker threads, right? And the worker threads performs the request, and it executes a callback to the main thread or the event queue, and event queue responses back to the application. Let's see, for example, if we go back to LinkedIn here, so the application. Now I have run this application in there, right? What happens is like whenever I have run this application, like let's say I'm making another request here. Okay. So this API is called, like this is the API operation, let's say, and it goes to the server, Node.js server, and Node.js server takes the request made by through this. It's a GET request, and by using event loop, this every request goes to the worker thread, right? It performs the requested data, and it executes a callback to the event queue using the event loop, and then the event queue goes back to the application, taking a response from here, this response. In other words, this response got back by the requester or the user, right? From the next video, we will get familiar with the Node.js playground environment. Till then, take care.